I'm just checking this out. Let's jump straight into it.
To integrate wavelet-based processing into your server, you need to consider the following steps. Wavelet denoising. If wavelet denoise is true, you can apply wavelet-based denoising to the data. Wavelet transform. This will allow you to transform the signal using wavelets. The kind of transformation depends on the value of the wavelet transform parameter. Wavelet decomposition levels. This indicates the level of decomposition you want in the wavelet transform. The following modifications to your code will integrate wavelet processing.
Right, let's start integrating this. Let's check for any no suggestions. From GitHub. Oh, nothing.
For the wavelet denoising, the universal threshold is used here, 0.5 *MP, sqrt, 2 *np.log, then, eg_data. This is just one of many thresholding techniques you can use for denoising. You might want to adjust this or offer multiple options.
That should be fine.
The wavelet used for decomposition, wavelet transform, is directly obtained from the client request. You should ensure that this is a valid wavelet type supported by PYWT, e.g., DB1, DB2, R, etc. Consider adding some error handling or validation for this.
This sounds legit. What else? While it's generating.
The level parameter is also directly obtained from the client request. Again, you should ensure that this is a valid value. Too large a value might result in an error or undesired behavior. If you wish to use wavelet coefficients for other analyses or visualizations, you can extend the code accordingly. The above example just applies denoising.
Right. Yeah, we also have the outputs. Just making sure it's the correct ID. Yes. Right, so want to do some error checking first.
Absolutely, validating the input is crucial. You can achieve this by checking if the provided wavelet transform is in the list of wavelets supported by PYWT. If it's not, you can send an appropriate error response to the client.
Right. Let's pop this before here somewhere. Okay, we do get an error. This is not the type of error I was expecting. Do we get it even if I remove this? And no. Okay, can we print out this list? Why Copilot doesn't want to work? Is it doing something? Ah, right. So you can just do that, can you? Right, this is the list. Okay, we need to adjust this drop down. Do they actually have names? And let's pop it back into GPT.
The list you've provided appears to be the wavelet names supported by PYWT, and the log entry suggests that a request was made with an unsupported wavelet transform value, UWT.
Yeah, are any of them legit? No.
Given this, it seems that the validation code is working correctly. When provided with an unsupported wavelet, UWT, the server responded with a 400 bad request.
Yeah, that's
If
fine.
you're looking to improve the error message for the client, you might want to include the list of valid wavelets in your error response. Here's a modified version of the earlier code to achieve that.
Oh, but how do we? Can we update this HTML bit? Can we update this? Wait a second, so those actually... So those should be correct responses, is it? The WT? No. Okay. We want to update this with the valid wavelets. Need to clear that. Run this. This at the valid wavelets. Shall you understand the context? Okay, updating the value. This value is not a valid value. Or is it okay? Okay, let's try this. It should be updated. It's not giving an error now. Okay, we might add more later. Should we do it now? Because we'll forget later, wouldn't we? Okay, give me... Right. It's the DB3. Yeah, there's a gazillion of them. Okay, let's just add 4. Should be enough. Okay, you know what to do, don't you? Is that same too? Yes. Right. Okay, that's enough. A bioorthogonal. Come on, GitHub Copilot. Why aren't you doing it by yourself? Shouldn't be hard, should it? is diff. There is no 1.2, so thank you for that. 1. Yeah, there's 1.1, 1.3, 1.5, and 2.2. Okay, we'll leave it that for now. Oops. Yeah, this. We need another input for let me check. Yeah, let's make this one default in HTML. How do we do this? Default. No. Come on. Give me something. Nothing. Yeah, GitHub Copilot. It's either I don't know how to use it, or it's absolutely hopeless. One sec, what are we doing? Missed this one. Well, having a problem. Can we make default option? Can't spell. Yeah, GitHub Copilot can learn from ChatGPT how to modify code. Yeah, I just need to add the word selected there. Right, so now we have DB1 as default. Now, obviously this should change the signal. Okay, this stopped working. Okay, what's up? think I had this error before. How to fix. Can you fix this?
The error message indicates that the variable eg_data is being used before it had been assigned any value. Specifically, the line.
I haven't saved this file as well. What was the last change? So this line is doing what?
Is attempting to pass eg_data to the PYWT wavedeck function, but eg_data hasn't been defined yet in the current scope. This is the cause of the unbound local error. To fix this issue, you need to ensure that eg_data is defined and initialized with the appropriate data before the line of code mentioned above. Here are some steps to troubleshoot and fix the issue.
Yeah, what do I have to do?
Check the context, review the code in your get_data function, and see where eg_data is supposed to be initialized. It might be possible that under certain conditions or input parameters, the initialization is being skipped, leading to the error.
So line 87. It's not indicating any problem. Just restart the thing. Okay, it's working okay. When I hit wavelet denoise, I get this error only when selecting wavelet denoise. Is on, and this is the error. Can you give me a more specific answer? Yeah, if wavelet denoise is over there, what's the problem?
Ensure consistency. If eg_data is initialized in the else block or outside the wavelet denoise condition, then you need to ensure it is initialized within the wavelet denoise condition too.
Yeah, it doesn't have an else function. Gonna try. Copilot is doing something. Right. do some manual with printing coefficients. Why? Not sure.
Ensure consistency. If EG_data is initialized in the else block or outside the wavelet denoise condition, then you need to ensure it is initialized within the wavelet denoise condition too.
Okay, error handling is good.
It's also a good practice to add error handling mechanisms. For example, before you try to use EG_data, you can check if it's none or not initialized and handle the error appropriately, rather than allowing the application to crash. Logging. Add logging statements to your function. This will allow you to trace the flow of your program and see which branches of your conditional logic are being executed, and the values of key variables.
Okay, let's do some more error handling. It should help. Let's try. Okay, so instead of oops. Okay. Right.
This would catch the unbound local error and return a meaningful error message to the user.
Okay, now the app is having an error. Don't have else yet. Okay, so this is running okay. Why is this not sending this? Okay. What am I doing wrong? What am I doing wrong? If wavelet noise this just be reverse. Multi-level discrete wavelet transform. Yeah, this doesn't make any sense. Now to fix the code. Sorry, no super long prompts. I'll probably get a timeout soon. But I'm just trying to understand what's going on.
The EEG_data variable is used to decompose the EEG data into wavelet coefficients. However, you're reconstructing EEG_data from coefs and then immediately decomposing it again. This doesn't make sense and is the main reason for your error. You should first obtain EEG_data from your segment and then perform wavelet denoising if the option is enabled. EEG_data should be initialized before checking for the wavelet denoising operation, or after extracting the segment from the dataset.
Okay. So we have that. We have this. Right, so this should come first. Yeah, don't want any comments like that too. Because it's obvious that that's a continuation of the code. Where is if? Do we have if the trend? We do. Okay, now I'm really confused. Yeah, that's just checking for nans. So this should go EG data, then the trend if necessary, then removing checking for nans, and then wavelet denoising. Rest of the code. Okay, let's try this. It's restarting the thing. Let's refresh. This is working. Okay, that's working. And it's actually doing something. So it's removing some noise. This is actually only useful up to a very limited point. Let's reduce the window size. Yeah, so you can see the noise reduction there. So yeah, ChatGPT 4 is does know something about EEG. It's a particularly noisy channel. This is detrending. This filter orders only. Yeah, we need to restructure the whole thing. We could actually just okay, let's try this again. Yeah, I want to know how to. So on the larger screen, ideally everything will be set from left to right. On a smaller screen, on a tablet or phone, yeah, it's obviously will have to go top to bottom. But otherwise, it's actually working. It's actually doing something useful. So next thing will be patching it up a bit and publishing on the side. So it will go, instead of this one here, we'll probably put it up top there. So it will eventually look at least as good as this one. If not, should be much better. So hopefully you'll be able to test it yourself. Oh, is it going? Yes, this levels in HTML should be limited. Levels value. Should have a min and max like that. IT. Equal. Well, would 0 just be the same as having it off? Yeah, let's make it 5 and default about 2. Right. Yeah, there's not much difference between the different wavelet types. Now the other thing is when I change the frequency spectrum is updating as well, which is good. Yeah, it's changing by bugger all. Yeah. The question is, this is working now with no errors.
Now that the immediate issue is resolved, I would recommend periodically reviewing and refactoring the code for performance, maintainability, and readability. Moreover, always consider adding more comprehensive error handling and logging mechanisms to make it easier to diagnose and fix potential issues in the future.
Right. So the thing is, so we did that. The effect of the noising is there, but not very clear. Let's see what it says. Maybe definitely knows way more than I do.
Denoising using wavelets can be subtle or pronounced depending on the nature of the noise in the signal and the parameters used in the denoising process. If the effect of denoising is not as clear as you'd like, you might consider adjusting some parameters or trying other techniques to enhance the results. Here are some suggestions to potentially improve the denoising effect. Adjust thresholding. The thresholding step is critical in wavelet denoising. You're currently using a universal threshold. You might consider adjusting the threshold value or trying other thresholding methods, such as the soft or hard thresholding provided by PYWT.
Okay. Wait, that sounds very interesting. Can you give me the details?
Certainly, the thresholding method you use in wavelet denoising can significantly affect the results. The method you're currently using is known as the universal threshold. Adjusting it or using other methods can give different results. Here are some ways to play around with the thresholding. You can adjust the multiplier, currently 0.5, in the formula to see if a different value gives better results.
Should I have it as an input?
The PYWT threshold function has a mode argument that allows you to choose between soft thresholding, default, and hard thresholding. Soft thresholding shrinks coefficients that are smaller than the threshold towards 0, while hard thresholding sets coefficients smaller than the threshold to 0. Another commonly used threshold, especially for signals with Gaussian white noise, is the minimax threshold. This threshold can be estimated as Shor shrink is a method that aims to minimize mean squared error, MSE. It involves a bit more computation, but can sometimes give better results than the universal threshold, especially for signals with non-Gaussian noise. Bayes shrink is another adaptive thresholding method that's based on a Bayesian framework. The main idea is to estimate the threshold based on the variances of the signal and noise. It requires additional computation but can be more robust in certain situations. It's often beneficial to experiment with different thresholds and thresholding methods to find what works best for your specific dataset and application. Visualizing and comparing the denoised signals with different thresholds can be very useful. Also, remember that it's not always about achieving the cleanest signal, but rather preserving the important features of the signal while reducing the noise.
Wow, you're so smart. Okay. So yeah, let's add the multiplier. We might continue this next time, but yes, we made quite a bit of progress that denoising actually works. I assume this number should be between 0 and 1. Yeah, GitHub compiles as 1 or 2, but yeah, it's definitely, the original thing was 0.5, so